Excellent. Okay, good afternoon, everyone. It's about 2 o'clock, so our lecture times are between 2 to 3:15, Mondays through Wednesdays. This will be a hybrid style class. So some of you will be online, some of you we will be in person. Uh, and we will kind of go through the meeting space and everything as we go through the introductory slide deck. So um, we will meet Monday and Wednesday all the way up until we have our finals. And the semesters go really, really, really quick. So let's kind of run through it to give you a pretty much overview of what system programming concepts is. I think I have a slide in there where I get to introduce myself, but you know what? I'll introduce myself now, and then I'll reiterate the portion in the slide just so that everyone's aware. I'm Ted Holmberg. I am an instructor. I typically teach Java 1. I've taught Java 2. I've taught system programming concepts just last semester as well. So I got a chance to cut my teeth into it this semester. I'd like to take what I think worked and what didn't work and improve it. I typically also, around this time of the year, teach the web applications class. So I teach some of the introductory classes, I teach some of the advanced classes, and now I get to teach the system programming concepts class, which I think is a really fun class. My primary role with the department is to serve as the industry liaison. This allows me the mechanism to kind of interface and talk with people who are in industry to figure out what skill sets they would like you to have going through our curriculum so that you're as employable as possible. So we'll go ahead and use feedback from our industry partners to try to adopt technologies and frameworks and just different concepts that would behoove you to know moving forward. So for instance, you learn how to use Git in Java 1 and Java 2. One of the motivating factors behind that is that Git's a industry used tool that is that you should know before you ever go into industry. Anyway, with that said, let's talk more about system programming concepts. So system programming concepts is kind of a continuation and it's going to be an extension of your computer science education. So I consider it part of the kind of introductory sequence. If you think of the introductory sequence as being the set of cascading classes that kind of unlock from one to the next until you're given the option to take whatever classes you want in computer science. Well, that's going to be, if you were able to lay that out in kind of a tree, then this would fit very nicely in the middle of that tree. So as you might recall, you've gone through Java 1, that was like an introductory class. Then you were given the option to go into Java 2, which is the second half of Java 1, and you were able to take assembly. So Java is our high-level language. Assembly would then be your low-level language. After assembly and Java 2, you can then take data structures, which is a very high-level class, and then you take system programming concepts, which is going to be kind of this intermediary class that we're going to see that sits between high-level and low-level programming. And then after you go ahead and say system programming concepts, that's pretty much, and data structures, that's pretty much the end of the intro sequence. And then you could take things like OS, programming language structures, or whatever kind of auxiliary classes, whether it's like graphics or game dev or cybersecurity or whatnot that you might be interested in. So this is a pretty fundamental class. We'll talk about a little bit more about why that is moving forward. So let's jump to the next slide before I talk too much. Oh yeah, my introductory slide. So yes, I'm Ted Holmberg. I do have an office. It's in Math 347. My office hours are, well, certainly they're not going to be that. That would be ridiculous. Can't have my office hours be my be the lecture hours. So let's correct this. Let's make them Tuesday and Thursday, and let's say we make them like 1 to, oh, that's perfect. Like 1 to 3:15. And I think that will work well for me. Okay, so Tuesday, Thursday from 1 to 3:15. But also I'll probably the way that I prefer to do office hours though is not in person. I prefer to do all of my class discussions inside of the Discord server. So how many of you here are members on the departmental Discord server? How many people know that that exists? Let me first. Excellent. Yeah. Let me jump. While y'all are responding to that, let me jump over here. So we have, of course, the UNO CSCI server here that is designed. This was really an invention out of necessity when we were all remote strictly because of COVID. We lost a lot of our in-person ability to kind of have a community where students could interact with other students. So we had spun up this UNO CSCI Discord server, which is now it's now filled with like industry people who have been employed since then, who are part of the UNO curriculum, who are graduated from the UNO curriculum. We have students at all varying levels, from freshman all the way to senior and graduate level. You can come here to talk about just whatever with your students, general talk, off-topic concepts, but they also have places for you to chat about all of the other classes you might be enrolled in, whether you need to ask help for a particular assignment or ask for a syllabus or just find out how the instruction is per professor level. We don't do much in terms of throttling your ability to kind of communicate with other students here. Now, with that said, if you go to, let's see, 2467, that's what this class is. Yeah, there's a little bit of a chat channel here, but really where you should go is going to be, if you follow the syllabus, I actually have a Discord just for this class. Now, the nice thing about having Discord just for this class, and here it's going to be this one right here, is that, and only, yep, I can see some of you have probably already started joining it. But if you come here, we have the last course, last semester's students are here. So we could kind of crowdsource the ability for everyone to help each other. So one thing I like about trying to manage an online space, especially in the wake of having these hybrid classes, it allows me to unify the in-person students with my online students so that we can have one cohesive community where everyone can come together and kind of jointly discuss and ask questions or explore the concepts that we'd be talking throughout the course of the semester. And you can not only just ask questions amongst yourselves, but now you have access to those students who have opted to stay inside this server for from last semester as well. And so you can pull from their expertise and ask questions that they might have had issues with, and then you could get some resolution and some answers on. So I do highly recommend everyone come and join the Discord server. You should have a link to it inside of the syllabus that went through the email. I will say, I am slightly disgruntled with UNO taking away all of my Moodles and making me have to remake all my content on Canvas. So wherever I was a very heavy Moodle user, I'm going to be a very light Canvas user only because I don't feel like remaking all the content I once made to redeliver. So I'll probably use the Discord server as my main mechanism to deliver content to you. Excellent. And if at any time you have any questions throughout this initial introductory lecture, please say so inside the chat, which let me open up here again. Excellent. Okay, so I will have office hours, but I'm going to state that I do prefer to hold all class discussions inside of our class Discord server. I think that that's the best way for everyone to kind of be engaged and part of that question answer discourse. Okay, quick overview for today. Today will be a light lecture. I don't want to overbog everyone. It's the first day of class, so I like to kind of ease into things. So I just like to leave you, impart with you Oh, that's not good. The Discord link in the syllabus is for a different Discord. Okay, let me do this then. Let me see, first of all, let me make sure this is correct. Let's jump here. Or actually, I don't even have to check to see if it's correct. I'll just share it in chat. Let me go over here and here. Close that. Go here to my server. Let's invite people. Let's create a let's edit this link. Let's make this link such that it never expires. There's no limit. Let me generate that link. Excellent. So now I have a link. Let me go into the chat with everyone here. And so here I'll just make it easy. There should be now a Discord server link that I just generated. Hopefully. No, I'll have to correct that for the syllabus. I don't know how that occurred. Okay, so I'll fix the syllabus link. But for now, everyone use the link that I posted inside the chat. And that should get you to the course Discord. Okay, so here, everyone should join the department Discord so that you have access to the student body at large, but also join the class Discord so that you have access to your cohort who's going to be a part of system programming concepts for this lecture. Okay, so moving forward, just a quick overview of what we'll be talking today. A welcome. This is a welcome session. We'll talk about the motivations for the course. We'll talk about the workload for the course, and some of these concepts will be refactored based off of what I've learned about how to teach this course from last semester. So we'll talk about that when I get to that slide deck or those set of slides. We'll talk about the readings for the class, and then finally, how will you be graded? Okay, so quick discussion of the objectives here. Well, so what is system programming concepts? Well, we could think of our system programming concepts, as I said earlier, as we're going one layer lower, or we're going to explore the layer lower under our higher level code, but above our very low level code. So we're going to see that in order to take this class, it's kind of expected that you've taken Java. I think is it Java 2 that you're expected to take? And I want to say it's Java 2 and it's assembly language that unlocks your ability to take system programming concepts. And Java 2, it also allows you to take data structures. So Java 2 kind of unlocks a kind of a sophistication in your ability to alter code so that you can go up one higher level of analysis and design considerations to start evaluating how efficient is your code base. So you can start doing analysis on like mathematical analysis to actually produce measures on how well your code is constructed in terms of optimality. And optimality might be how much your computational time or your memory efficiency. Now, on the flip side of that, when you took assembly, that's very low level. There, you got a chance to touch the registers, and you had access to your pointer and pointer controls, and you were able to effectively learn how you effectively had a stack that was used to manage what instruction was being executed at any given time. And so you really got to see the grizzle of how the higher level statements you create are kind of executed at a very kind of granular level when you hit your instruction sets. So one of the things about our system programming concepts is, as I said earlier, have you ever wondered how your compiled code, your Java code, for instance, once it's been compiled, how it then runs on your system? And these are going to be some of the concepts we're going to explore in system programming concepts. So, of course, we're going to introduce the idea of that. And also, we're going to introduce the idea of just programming at the system level. So, effectively, an application that's designed to help run other applications, because that's what system programming is really looking to do. We're going to examine this in the language of C. So up till now, you've had a chance to use Java in 1583 and 2120, and you've had a chance to use MASM, I believe is the programming language you use inside of 2450 for our assembly language. So really, when we use C, you're going to see that it's not going to be that different from some of the concepts pulled from those two different directions. One of the advantages of using Java as the initial language is that it's technically part of the C family. So C is kind of like the base language in which the C family is derived from. Then you have C++, which effectively takes the concept of object-orientedness and bolts that onto C. It adds that, enhances C with that, hence the name C++. It's an increment of C. And then Java then goes ahead and rebuilt an entire language using the C paradigm, but in a way that is very portable because you run on the JVM, and it's designed to be an object-oriented first language. So the idea of object-orientedness was baked from the beginning. But you'll see a lot of the syntax, a lot of the formatting, a lot of the way that we author our code is going to be very consistent across C and then C++ and Java. Now, Java does abstract a lot of things away that you have to have concerns about with C. So the idea of like passing by reference, the idea such as garbage collection, the ability to have like the class keyword, all these were inventions or additions after C. So C has access to pointers, and you have to be able to allocate your own memory. And so this is where C will become more like assembly. So C is this good kind of convergent middle ground. This is why C is still very popular. C can be used to create very, very efficient and performant code. So if you're building a system level application where you're potentially having to talk directly to the OS or talk directly to like drivers for hardware, and you want to make it as incredibly fast and hardened towards that particular hardware, then C's a good choice for you. There's a reason why a lot of operating systems are actually authored in C. There's a reason why C has lasted for decades and decades now. There's a reason why a lot of high-performing video games are authored exclusively at these lower. It's a high-level language, but one that sits as close as you can to get as performant and as efficient as possible. In fact, a lot of other popular languages, like say, for instance, Python, actually it was written in C, and it kind of exists on top of C to be able to do the task of being able to author and pipe your code, these common tasks together inside of like a scripting environment as readily as possible. And so, like, for instance, if you do any Python programming in particular for like data science, where you're using large volumes of data, what makes that so performant is that it relies on and will import a lot of C codes, and it has just Python bindings to allow for that. So C is a very good language to learn, and one that's really good when we're talking about system level programming, when we're talking about operating at a Unix level. I'm going to give you a chance to kind of explore and expand your set of languages by one more. So over the course of this class, you're going to learn really what happens underneath the hood when your program runs. So up to this point, that part has been kind of magic to you. We tell you in Java 1 and Java 2 to compile your source code with Java C. We then tell you to go ahead and like run your source code with Java, right? But how that application is running inside the system hasn't been kind of defined for you. So that's been a boundary that we've kind of kept as this mysterious black box up until this class. In this class, we're going to kind of lift the curtain there and explore what's happening after we compile code and we want to start to run it at our system level. When you type in Java C and then your source code file, what is the bash shell doing? What is the shell environment doing in order to be able to compile your code. When you run Java and then your source code, whatever the object file is, what is our shell application doing in order to then execute your application so it's running inside the system. And of course, this entire class, this concept only starts with system programming concept. It then is going to motivate the much more important concept that's going to follow this class, which is going to be operating systems, which will take you one level even down below that, where we can talk about an application that's designed to manage all the processes running on side of the system and how that works. So, as you could probably be aware based off of my very lengthy explanation up to this point, the prereqs are 2120 and 2450, right? Because we're hitting that middle ground. You need to know kind of how to author code so that you can really appreciate what system level programming is all about. But at the same time, the way that our application is going to exist inside of our system is going to be built on top of the back of assembly. So of course, in this course, you'll be expected to have experience in both those so that you can utilize that at both. So again, high level programming concepts with Java, low level programming concepts with machine assembly language, and then we'll just kind of converge those two. And of course, what you should get out of this is the course should strengthen your knowledge and skill in both these areas and take what are probably two disparate knowledges, which is your high-level programming skills and your low-level programming skills, and start to show you how these seam together so that this concept, the concept of computing in general becomes more this seamless kind of a seamless space that you can kind of understand where high level flows into low level and then actually accomplishes what it's supposed to do. And so trying to remove as many kind of barricades for you as possible so that when you start to author code, you can kind of understand how to make it as efficient as possible since you'll know how it kind of flows to the underlying system. Okay, so the knowledges you'll acquire, you'll learn more about low-level data representations. So we'll do some hands-on with bit manipulation. You might have had a chance to kind of dip your toe into this pool in assembly. We will continue that, that kind of exploration. Let's see, other things you will learn over the course of this semester, how C programs become machine instructions. And so when we see how C programs become machine instructions, we can then extend this concept out to any other kind of source code that will then become machine instructions. We'll also look at how running programs really works in terms of the function call stack, in terms of how this works at a system level. When we go to run an executable, we'll look at exceptional control flow. So again, as you're operating inside of a shell, and so I think at least in Java 1 and probably in Java 2, most of your experience relies on doing everything at the shell level. So with that said, there's a lot of stuff you can do in the shell. You can move around the directories, right? You can list the contents inside of a directory. You can go ahead and launch a Java application. You can often pipe things from one application to another using your shell. You can go ahead and redirect input and output, which helps facilitate this concept of piping from one application, from one shell level application to another shell level application. So there's a lot of interactions you can do with the shell. Shells can contain text editors, right? They can contain compilers. These are all applications that you can run using commands and then feed that into other shell level applications or be able to do something with the resulting files. So for instance, when we call a compiler with Java at the shell level, it compiles code that then goes onto your system. And then you can access that system with some other application. So for instance, our Java compiler can compile our Java source code into object code. And then we can take that object code and send it to the Java runtime environment, the JVM effectively, and be able to actually launch that into the system, which then probably spawns its own thread, forks its own thread, and then runs that application. So we're going to learn more about how the shell does that. That'll give you a deeper understanding of how system level applications work. But on top of that, the processes, which is what our executable applications effectively become, these processes have the ability to communicate with other processes. So if the shell is a process, if our Java application running in memory is a process, where there's a mechanism that allows one process to communicate with another process, that's going to be with our exceptional control flow. So processes can send signals to other processes to be able to interrupt them, for instance. So for instance, when I'm in a shell and if I'm running code and then, oops, I actually did a, let's say I did a, here, actually, let me show you. Let me move this up the way. So suppose that I run a, well, I'm not going to do this. I don't want to potentially eat up all my my memory by accident. But suppose I do a infinite for loop, right? Or an infinite while loop in my code. And if you're running that, you're like, oops, this is an infinite loop. What can you do? You can hit Control C, and all of a sudden that loop is interrupted. That application that is kind of stuck in that infinite position is interrupted because that signal was sent from one process to the next to make it stop, to tell it, okay, no, you got to quit. And so when you were doing simple things like this, these are all tasks that are managed by the shell for us. And we're going to, over the course of this semester, kind of explore and see how that operates. And then finally, this class, there's a reason why this class is the prereq before OS. We'll see how programs can interact with the OS and kind of run concurrently. And then this will motivate you to understand next how we're then going to take one step lower and start examining how the operating system actually works. And that's what you'll do in 4401, which is the class after this class. Okay, so some skills you will develop. You'll learn how to use Unix command lines such as bash or make or text editors or GCC. I highly encourage you to explore the shell and all the shell level applications so that you can become well acquainted for using the shell as an environment by which you can just open up files, you can edit files, you can walk your space, your directory space on your system, and then you can access various applications and whatnot from there. We'll take and explore systems level programming in C in particular, as I said. We'll also introduce some tooling you might not have seen, which will really facilitate the course, but also facilitate your ability to develop or harden your ability to develop, and especially as it comes to debugging, by introducing the concept of a debugger. So we'll look at the GDB, which will be a console level. It'll be a shell level debugger. We'll learn how to do a lot of the class, and we'll see this in the next slide, is going to be driven by applicability. And so we will learn how to do things in very practical ways. And hopefully, if we can get to it, the kind of capstone project that kind of motivates the cybersecurity program here would be to execute a buffer overflow and use code injection to take control of the program. So you can kind of see how nefarious agent, how someone could potentially utilize their system level programming knowledge to exploit a system and run effectively unsigned code, thinking that the code is okay. And then finally, the last skill that we want to kind of develop would be mastering the process control by writing our own shell. So the way that we're going to kind of explore all of this over the course of the semester is going to be with hands-on lab assignments. And this will be a very big majority part of the course, a big majority part of your grade. Now, I think what I found working last semester was that I'll likely will walk through these labs with you. So we'll have an introductions lab that will show you how to use C at large. So there'll be a total of at least 5 labs. And again, this is the way that I'm presenting this content is always in flux, right? I'm always learning how to improve, how to teach this content. So everything inside of my syllabus, I leave as subject to change. So on this instance, this is what my plan is, and this is what I was able to achieve last semester. But I'll try to explore to see if I can't extend it even beyond what we've done last semester. We'll see. It all depends on the give and take we have. But as of now, the labs we're gonna do are gonna be an introductions lab, which is going to really challenge you in being able to use just the C programming language, which should be relatively simple conceptually as it maps pretty nicely to Java. And so when you submit all of your source codes in this class, it should be submitted through AutoLab. AutoLab will auto grade you. So at any point, you'll know instantly what your lab grades are. You can just look at the AutoLab grade and that'll map over towards what your lab grade is. So the introductions lab will be a C programming challenge. Then the data lab will challenge your ability to understand how to do effectively, how to operate on data in terms of binary formats. So it'll ask pretty interesting puzzle-like questions, like, can you get this operator? Can you build an operator, like say, for instance, the AND operator without using the AND operator? And then, produce the results you'd expect it to ensure that you understand how the transformation of data in binary sequences using the classical operations you're given, how you can get those to actually, how to fundamentally know how those work. Because that'll kind of motivate your concept towards how our binary data transformations work. The bomb lab will go ahead and really teach you how to use the debugger. The attack lab will be a continuation of the bomb lab. That's going to be where we try to do our code injection. And then the shell lab is where we're actually going to build a simplified version of a shell we'll call Tiny Shell all on our own. And so really that'll give you, I think, the best understanding of how a system level application actually works. Now, I'm getting some questions. Is it okay if you've never programmed in C before? Yes, absolutely. One thing you should know about the curriculum we have designed from the entire intro sequences, we don't expect you to come in with any knowledge that we haven't already taught you. So when you start 1583, there is no expectation that you knew how to program anything in Java. Everything that you were going to learn was going to be covered in class. So it was all effectively tabula rasa, a blank slate. And then we taught you what we thought you needed to know so that you could cultivate and become a Java developer. So continuing with that in mind, continuing that same kind of concept, when you enter into system programming concepts, the only thing we expect you to come in with are those things that are listed inside of the prereqs. So it's going to be those knowledges that you've acquired from 2120 from Java 2, and those knowledges you've acquired from assembly. And then we're going to take those together and introduce new concepts like C, and we're going to see how we can go about and do everything in C. And since this is the second time I'm teaching this class, you're going to have a much better advantage than the prior class did, especially when it comes to trying to discuss and talk more in depth about some of these concepts you might not have seen before. And so I'll mention that in one of the future slides, but all of the recordings that we have will be able to kind of access, such as the one I'm recording right now. So let's talk a little bit about classwork. So the workload for this class, I guess, could really be considered significant because it is a lot of labs, but it's my intention that we can walk through the labs during our lecture period. And so what I'll do is I will log into the environment that we have access to. I'll show you what that is. It's going to be a web terminal, which is available as a web application right in everyone's browser. So you don't have to set up anything at all. In fact, you can't set up anything on your own system because we're actually running some applications on the Shells Lab workspace that you're going to have to access. So everyone's going to be expected to kind of use the system programming lab workspace, which I'll show you how to do in just a moment. But so the workload could be considered kind of significant because we'll be doing a lot of labs, but we'll be walking through the labs in class, and you'll learn a lot by doing the lab. Now, traditionally, the way this class was taught was you were challenged to do, I would lecture to you about on the textbook. The textbook is really great. Everyone should read it. But lecturing about the textbook with the textbook that's already, I think, pretty well written can be very boring. then it's just me kind of summarizing chapters for an hour and 15 minutes twice a week. And then you feel like you get lost trying to implement those into the lab. And I think a lot of people get frustrated. So I inverted the class where instead we're going to spend our class time walking through the labs, seeing how to practically do everything. But then now what I'm going to do is I'm going to rely on you then to be able to actually do the readings. And so that's where I'm going to have to flip the class, where to ensure that everyone's doing readings, I'll probably have the class have to do, we'll have to have some kind of discussion group. And I'd love it to be a peer-based discussion group to illustrate that everyone understands the more general concepts that drives the actual kind of explicit things we're doing inside of the lab. So we're going to probably try to flip the concept of how lectures work and treat our lectures as, okay, let's actually do real coding. Let's actually solve these lab challenges. But then I want you to go to the book. I want you to read the chapters on the book that are based off of what we're doing inside the lab so that you can have a more general understanding beyond the scope of what the very specific things we're doing inside the lab. And so that's going to be one of the things that is going to be an exploratory work over the course of this semester. Okay, now with that said, some highlights from the syllabus. Again, you're here, you know what time the lectures are. They're 2 to 3:15, Mondays and Wednesdays. If you're on the online section, then you have the Zoom link. Otherwise, I think Webstar says we're in Math 209, which is going to be one of the downstairs classrooms. The legacy page that will contain like all of the lecture slides and other materials is actually 2467.cs.uno.edu. So if I, just to show you what that looks like, that would bring you here. So this is the old legacy page that Matt Toops, who had first kind of developed this course content based off of Carnegie Mellon's system programming concepts class, is kind of hosted right here. So this is a good basis. Now, again, I'm going to change certain concepts, but here you can definitely access a lot of materials and whatnot that are good to access. Like for instance, this is, and then I'll also show you some other links that are good to know. So that is the old legacy page that contains some course content that you should be aware of. All of our AutoLab stuff will go to autolab.cs.uno.edu. You should be familiar with AutoLab because you use that, I think, in Java 1 and maybe in Java 2. So we'll be using effectively that same AutoLab server. So for lecture videos, a long time ago when we started to have to do remote classes, I pulled classes to find out what was the best platform that would actually be engaged upon in terms of class discussion. And that's why Discord was selected. What was the best platform for delivery of video content? And so YouTube playlists ended up being the more popular thing. So if you click on the YouTube playlist, that's going to be the entire playlist from last semester. So you have access from day one to every lecture that I did just a semester ago. From the introductory lecture all the way to the shell lab lectures where we did our various traces. And so this you can see is CSCI 2467 lectures 2023. I'll also start uploading the lectures from this semester onto a different and separate playlist. But at any time, if you want to get ahead from where we're currently at, I advocate you take advantage of the playlist that's already available. Here you have an option to kind of preview. So if you want to increase your knowledge on C, then you can watch some of the lectures I already have about going through the Essential C PDF or the textbook PDFs. In fact, the first half of the lecture, I was more tethered towards using the textbook as the source for lecture content. And then about halfway through, I pivoted to do walkthroughs, lab walkthroughs. So in this instance, I'm going to deviate our class this semester where things that I did lecture to the students very explicitly, I won't do again, but you also have access to it here. And that'll give you the opportunity to kind of explore earlier labs directly in person with you in our lecture time, with the idea that if you're reading the textbook and you're having difficulty understanding what it's saying, you can go to some of these lectures and kind of see what the lecture has to say about it. And the lectures usually change a little bit every semester or so until I find exactly how it is I want to kind of articulate the concepts. So you do have those lecture videos from last semester available, and you should have them for this semester as well. So let's talk about required textbooks. The textbook we'll be using is going to be Computer Systems, a Programmer's Perspective, which can also usually be labeled as this, as CSAPP or CS App, short for Computer Systems, a Programmer's Perspective. This is a really good book. You should get this book. It'll show you how to solve the labs. They do a really good job of explaining system level concepts. So for instance, there are two types of textbooks. After teaching classes for a number of years, I'd say there's two different types of textbooks that one encounters when you go through taking a class. You have what I think are kind of student biased textbooks, and you have instructor biased textbooks. And so the difference here is that a student biased textbook is kind of designed so that the student can self-guide themselves, such as the explanations are deep and kind of understandable enough that you can kind of read through. And it's trying to piece together those the concepts in a way that it's fully explained. Whereas other textbooks, which I'll call instructor bias textbooks, are very dense and they're very rigorous, and they might be like classically like more correct in the idea that they don't take a lot of time of having to build up a narrative. This will be a lot of times the data structures textbook might come off this way, but it kind of requires an instructor to help parse that content and kind of stretch the space of the density out so that they can they can provide input that makes it easier to understand. This textbook, I would say, is much more like a student biased one, where it's very easy to read. It takes a lot of thought and consideration in kind of exploring and explaining the concepts, so that without prior knowledge, it's very approachable. So you can read it and you can have great value in that. So I think this is a great textbook to learn from, especially for this class, since all the labs are explicitly taken from this textbook. And so I think also, based off of the way that UNO does the full access stuff, everyone should have access to this textbook through that. And if for any reason you don't, I might have to contact the library just to ensure that they've like added this course as the book for that class, so that you have that digital access to it. Now, other optional textbooks besides the required textbook, you have the quintessential C book. This is the C programming book, commonly referred to as the K&R book, which are by the authors of the C language, and also happens to be the authors of Unix, which, if you want to know, again, to reiterate why C is such a great programming language for system level applications, the same authors for C were the authors for Unix. So C was kind of designed to help build system level applications to begin with. Now, other initial readings and that you should be familiar with. So there are two PDFs that are downloadable. They are free, available from Stanford University. They act as a primer to the C programming language. So again, if you haven't had any exposure to C, these are great starting points. So you have this one, which will be essential C.pdf, and then you'll have this one, which is going to be, which will be the another short introduction in Unix programming tools. And so actually I have, if I'm not mistaken, inside the old lecture series here, a breakdown of the essential C PDF that's here, here, and here. And then I have a quick overview of Unix tools explored here. So if you want just kind of a quick, or if you want to have it depends. The Unix tools, I think, is very quick video. This, I think, is like a 3-hour primer set of lectures, kind of going into core concepts on how to use C, where you have access to that. Or you can just read the PDF, or you can do both, read the PDF and listen to the lectures, whatever works best for you to be able to learn the content. Okay, so what are the best ways to succeed at this class? You attend lectures, read the textbook, read the supplemental text, and do the lab assignments. And then we'll talk about how exams will work. Clearly, you need to take the exams to be successful. I'm not sure exactly how I want to do exams this semester. I'll probably do similar to what I did last semester. I'll state that the lab assignments, so there's 5 lab assignments that we saw, like the intro lab. We had like the data lab. We're going to have the shell lab. We're going to have the bomb lab, and then we'll have the let's see, what was the last lab that I had said? The attack lab. And those will be worth collectively 60% of your grade. And we'll walk through a lot of those in class, but then I'll probably go ahead and we'll do a kind of addendum onto those to make them a little bit more challenging for you in terms of having to provide some content. So we'll talk more about that as we approach that. Then in terms of the exams, typically what I do with exams is I don't typically do written exams. I usually do more or less oral exams where you have to register a time with me and I have you walk through a presentation of something that I'll tell you about ahead of time. So this is a good way for me to ensure that you kind of have the ability to communicate about these concepts in a way that isn't just regurgitating information, but a way that is like an operational knowledge, one that you can either encode using writing or be able to deliver through communication. I think that's probably one of the most critical skills that you could develop, and one that I don't think we do a lot of exploration with inside of academia. So you could think of exams as being something that's more going to be like a give or take. I do also recommend that all the assignments that you find effectively a partner with and work on everything partnered. So I do think paired programming is a great tool, a great mechanism for everyone to kind of be able to talk with some other member of the class and be able to kind of discuss the problem and work together to solve that problem. Let's see. And then you can either use the labs or you can just use the browser to be able to. It's not this, it's web terminal. Let me correct this. That's wrong. This is now webterminal.cs.uno.edu to be able to access that. And then if you want help, again, you can ask questions in class, or you can use the Discord server to facilitate open questions. We kind of discussed that. And so your first lab clearly is not going to be due in August. That makes no sense. That's a long time away. So let's make it due not on a Tuesday either. Let's make the first thing due. Let's see. It'll be sometime in January. Let's say we will make it due on Thursday. Let's make things due Friday. Fridays are a good day. Friday, January 22nd seems like a long time. What is the Friday of not this week, but next week? Oh, that's pretty close. Excellent. So we'll make this due Friday the 20th, which we'll spend more time actually talking about these concepts next class, obviously. Because this class is effectively just about introducing the concept and talking about what we're going to cover over the course of the concept. Oh, let me change that, 19th. And so let me see, what else do I want to show you before we move to this very last final part? This is here. Web terminal is going to be what everyone uses. If you type in webterminal.cs.uno.edu, it'll bring you to like a login screen here. Let me type in password and you'll use your UNO credentials. It'll bring you, and then notice I'm just in a browser, but this browser is effectively accessing, we run Guacamole, which allows us to effectively give you your systems level environment delivered as a GUI inside of your browser. So here I can actually like open up a terminal in here and I can go ahead and do all the things you'd expect, like ls, see what's inside of a directory, or be able to change into a directory, right? And then do else again. And so here we can see we have all the various ability to author our lab code in here. And since it's a GUI, so I would prefer if you use system level tools, but you can also use the non-system level tools as well, just the OS tools, the GUI based tools. Say for instance, if I go here, you could see here, that's intro lab. Actually, let's go here. So go to data lab for intro lab, or what's an example? So here I have factorial C. If I click on here, you'll see there's actually text editors that allows me to go ahead and edit text inside this environment, just as if it's a standard operating system. In fact, this is a Ubuntu operating environment we're inside of an OS. So you see, I get all the nice syntax highlighting. I could go ahead and execute this code inside of my command line here. I can also go ahead and what else is worth showing here? Oh, the other thing that's worth knowing that you'll need to know is if I go to applications and internet, I can even open up browsers and actually access browsers inside of here. So if you need to download, say, for instance, a PDF document, or if you want to be able to go ahead and for being able to, or in order to use as a basis for any of the lab work that you're working on, you can, if you're having trouble getting it into this environment, you can always just access it through GitHub or through your email, or just access the PDF or whatever required data here and download it directly into your lab environment. So any way that you'd effectively work on your own operating system from your local OS, you could do effectively inside this remote OS environment in Web Terminal. So get familiar with this environment. This is going to be the environment you're going to be using for the rest of the semester. Okay, with that said, I'd like to take the last few remaining moments just for everyone to kind of be able to introduce themselves with. So let me desist and actually just have everyone just say hi to one another. Hopefully everyone has access to a microphone or whatnot, and just kind of be able to have people map faces and names and whatnot so that we can make this start to feel more like a real class. So I will stop sharing. Also, I'll stop recording at this moment too, because this won't be as necessary.